Assalamualaikum warahmatullahi wabarakatuh. My name is Yunazri bin Yunalis. My matrix number B1325103115. So I'm going to talk about the introduction first. So basically we know the brake caliper and brake disc are essential component of a vehicle disc braking system. So they work together to slow down and stop the vehicle safely. In this project, both components were designed and modeled using Solidworks. The project aims to improve CAD modeling skills while providing a better understanding of the design and structure of automotive braking component. So the objective about this project is to design a 3D model of brake caliper and brake disc using SolidWorks. The next, to enhance CAD modeling skills through use of SolidWorks, and lastly, to produce accurate and detailed 3D mechanical component models. So this slide is going to talk about the software tools, which is assembly mate, motion study, revolve, extrude cut, extrude boss or base, smart dimension, and the sketch. So the workflow for the break this caliper is the first thing first, we meet together and discuss the idea. So after that, we study the part of breaking caliper. The next, we sketch in 2D to refer again and again. The next, create part of brake caliper. After that, we assembly of components and then apply it. Uh, After that, to find a break, and lastly, run simulation to analyze.
Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Muhammad Akmal bin Wan Mahzan and my matrix number is B1325100292. And now I'm going to explain about all of the components that are included in this project. So there are actually quite a lot of components in this project. So the first component is the bleeding screw. It uses titanium alloy as the material, and the bleeding screw used to bleed the system or flush the system. So what happens is when you loosen the screw bit, you can bleed the system by making sure there are no air bubbles in the system, and you can flush the system by loosening the screw also. And next is the bracket screw. There are three in total, as you can see here, and all of them use IC1045 steel cordon as the material. All three of them have different measurement, different design, and different function, and all three of them are going to screw onto the brake caliper bracket later on. And next is the brake caliper body. This is the main component of the caliper, and the material is aluminum 380.0. So next is the brake caliper bracket. It uses plain carbon steel as the material, and all of the all of three screw that I have mentioned before will be screwed onto this caliper bracket. And next is the brake pad. We have two brake pad in total, which labeled as the brake pad 1 and brake pad 2 here, and it uses brass as the material. As you can see here, they have a slightly different design when looking at the picture. For the brake pad 2, we have an extra design on the right side of the brake pad that looks like a C shape. So what that why is it different than the other one is because it is used to slot onto one of the screw that will be screwed onto the caliper bracket, and you use it as a support. So that's why it have extra design on the right side for the brake pad too. And next is the brake pad screw. It use IC304 as a material, and as the name suggests, its function as to hold the brake pad in place. And next is the brake piston. This is actually the most important part of the caliper. because if this piston is jammed, the whole system will fail. And it used IC304 as the material. And for the last three component is the brake disc, and it used 1060 alloy as a material, and oil seal. There are two oil seal that have a slightly different dimension. So the material obviously use rubber for both of the oil seal. As you can see here, the oil seal 1 is a bit thicker than the oil seal 2. Next is the final assembly. This is the final assembly view from the front view and the back view. And next is the side view from the right, the top view and the side view from the left. And lastly, this is the isometric view for the final assembly. And now I'm going to show you about the exploded view. And this is the exploded view for the bracket caliper. Like I said before, three of the screw will be screwed onto this. You can see it more clearly now on which part of the hole will be screwed onto. So for all three of these will be screwed onto two upper hole of the bracket. So next is the exploded view for the body, which consists of the bleeding screw, which is on top here, and oil seal, oil seal 1 and oil seal 2. We have 4 in total because we have 2 brake piston here. Why we have 2 brake piston here? Because this is actually the 2-port caliper. And lastly, this is the exploded view for the complete final assembly, which consists of all of the components that I have explained before. And lastly, this is the drawing which are labeled based on the parts here. You can see the list here and the label part on the right side here. And that is all from me. Thank you.
Assalamualaikum to Encik Zakaria. My name is Muhammad Farhan Hanif bin Fazli and my metric number is B1325103114. And for this project, I will talk about problem faced during work process. In the period of we doing this project, we face some problem, and the problems is difficulty in creating complex shapes and features of the brake calipers, challenge in applying accurate dimension and measurement, errors during sketching and feature creation, and time required to complete a detailed 3D model. Thankfully, when we faced these problems, we got the solution to it. And the first solution is we refer to engineering drawings and dimension carefully. And the second solution is we use Solidworks tutorial and online references to solve the modeling issues. The third is we check and corrected the sketches before creating the features. And the last one is we divide all the modeling work into similar section and review the model regularly. Now I will talk about gravity analysis. Before we talk about gravity analysis, I would like to tell you about what is gravity analysis is all about. Gravity analysis in this project is it was performed to evaluate how the brake caliper and brake disc respond to their own weight under the normal gravitational force. This analysis helps verify the components are structurally stable, identify potential areas of stress or formation, and ensure the design is suitable before carrying out further simulations or manufacturing. And I will talk about gravity analysis of brake calipers. Gravity analysis was carried out on the brake calipers and brake discs using SolidWorks simulation. Second is material properties were assigned and appropriate fits restraint were applied to represent the actual mounting conditions. And the last one is a gravity load of 9.81 meter per second squared was applied in downward direction to evaluate the effect of each component self-weight. That's it from me.
Assalamualaikum. Hi, my name is Wan Muhammad Syakir Iman bin Wan Muhammad Syaril. My matrix number B1325103034. Today, I will talk about fluid pressure in piston, which means the test to get the analysis on the project. Next, look at the stress analysis for our dual piston brake caliper prototype. Look at the diagram on the left of the slide. The red arrow represents the hydraulic fluid pressure. This is the force pushing the piston forward against the brake pads. The green symbols show our fixed mounting points, which are where the caliper is bolted tightly to the suspension. On the right side of the slide, we have our result. The color scale show how stress is distributed. The blue means very low stress, while red show the highest stress. As you can see, the stress is mostly concentrated right on the piston face, which is exactly what we expect. Our maximum calculated stress is very low at 0.224 Newton meter per second. This initial run confirmed that our setup is working correctly and the design can safely move on to the next. Next, let's move on to the displacement analysis. Also, for our piston brake caliper, the purpose of this test is to visualize exactly how much our component deflect under operational loads during this testing phase. To keep our testing condition consistent with the previous stress analysis, the red arrow you see here simulate the hydraulic brake fluid pressure directly forcing the piston forward. The green symbol represents our fixed constraint or mounting points holding the caliper assembly in place. If we look closely, the color gradient on the plot, the warm color indicates that the highest amount of movement occurs right at the center of the piston face, which is exactly what we would expect dynamically. However, looking at the quantitative data, our maximum displacement is exceptionally low, measuring at just 8.024 times 10 power of negative 9 millimeter. In practical terms, this microscopic level of deflection tells us that the prototype is incredibly rigid. This is a great result because it means minimal energy is lost to component deformation, ensuring that the hydraulic force is efficient, efficiently transferred into braking power. Overall, the structural integrity looks very promising at this stage. Finally, let's take a look at the factor of safety analysis, or the short form is FOS for our brake caliper. This particular plot gives us an angle view of the entire assembly, allowing us to evaluate its overall structural safety factor and ensure the design can effectively resist mechanical failure under operational loads. For this simulation setup, the green symbol highlights our fixed restraint, which anchor the system at the center hub. The purples or the blue arrows simulate the applied structural test force acting on the assembly. When evaluating a design, we want to see a factor of safety well above 1.0 to guarantee against failure. If you look at our data, our maximum factor of safety reached an incredibly high value of 1.0 minus 10 power of 16. Even at the minimum range shown On the color scale, our value remain exceptionally high, with the lowest area sitting comfortably around 2.9 times 0 power 6. What this tells us in practical terms is that our current design is massively over engineered for the simulate loads. It provides an extreme margin of safety against structural failure, meaning we have plenty of room to optimize the design, potentially reducing material weight or cost in the next prototyping phase without compromising structural integrity.
Assalamualaikum. My name is Ahmad Shafiq bin Muhammad Isairi. My matrix number is B1325102889. Today I will talk about impact force on black disk. The stress analysis in the impact force on the black disk. This is a one measures stress analysis from a different angle on the disk bed prototype. The green symbol that you see is represent the fixed distance holding the rotor center and caliper mountings in place. The purple dots simulate the torque or force distribution across the assembly, displaying how stress spreads into the caliper housing during this prototype test phase. You can see the maximum of the stress is 3.097. Next is displacement analysis. Maximum displacement is 4.27. This is displacement analysis raised from an angle view on the displaced prototype. The green symbols indicate the fixed restraints at the center hub. The purple arrows simulate the operational force, visualizing exactly how the outer edge of the rotor and the caliper housing flex or deflect during the testing phase. You see the green one is the one that getting the force that press the brake disc and the brake pad. Last one is a factor of safety analysis. Maximum displacement is 2.482. This is a factor of safety force analysis on the disc brake caliper prototype. The red arrows simulate the hydraulic fluid pressure pushing the pistons, while the green symbols indicate the fixed mountings. This plot evaluates structural safety, showing how well the prototype design resists material failure under the applied test conditions. The conclusion is we successfully designed the brake caliper and brake disc using the Solidworks. We develop our CAD modeling skills and gain practical space in creating accurate 3D mechanical components. We also learn about the new feature, about factor safety, how to do simulation, how to perform uh, the design. Overall, this project improved our understanding of the engineer design process and the application of simulation tools in mechanical design. That's all for from us. Thank you, Sir Zakaria.